Hi everyone. All right, so Vertex Form, we kind of quickly touched on it the other day. It was meant more to be an introduction, but we can discuss it further. It's totally fine. So here's some practice we're gonna do together with some steps. So we're gonna do Vertex Form again in 8.7 when we get there. So don't panic too much if you're not super comfortable with this vertex form stuff. The main thing is you understand the transformations piece. So listing out the transformations, again, we didn't go into a lot of detail in the last video with everything going on. We definitely need to do that. So when we have vertex form, it looks like this in the purple. Okay. When we did this in the video, we did have a B in here in front of the X. After going through and looking at kind of where we're going with it versus where you're going to go, like in pre-calc and E2 in geometry, you're not going to need the B with me yet. Okay, you're not going to do that till next year. And that's something that when you're in geometry that they can introduce. So the main thing is that we have this framework right here so you can build on it in geometry. So the first thing we're going to talk about is we're going to talk about horizontal shifts left and right. Okay, so you have vertex form here. You have a times x minus h, that squared plus a k. So you now have an h and k in there. I'll talk about what those are in a second. But you have this standard minus sign in here. So when that minus sign is a plus, that means you have a negative number inside that space. So you're going to shift left when it's a positive number in there. It's kind of the opposite of what you would think. So when it's a minus in there, a minus h, it means it's a positive number because it's not changing the sign. So remember we would say like opposite b over 2a. That's essentially the same thing we're doing here. This is opposite h, okay? So when you plug in a positive number, it becomes this minus inside, and when you plug in a negative number, it becomes a plus. So a good example is when we have a positive b over our 2a, and we have a negative b over our 2a. So we say opposite because these signs are going to change, right? So that's the same idea here. So when you have a negative, it is a positive number. That's going to be a right shift. Okay, so we're going to shift right when it's a minus h, and we'll shift left when it's a plus h. So again, we're not worried about the V right now, or the B right now. We're not going to do that. That's something for geometry and A2 to build on. So do not panic about the whole B. Okay, like let that go. Let it go, as Frozen would say. So the second thing we're going to take a look at is this reflect over X in stretch and compress. That's your A. That's the A in front. So this A right here is the same as the A that's in your trinomial, and you're going to see that in this example. So that's the A. The reflect, it tells you if you're going to reflect or not. And then the stretch or compress, you'll see if you have to do that. So then the last step we're going to take is we're going to do the vertical shifting up and down, which is our K. Okay, so the K on the outside, that's a normal, whatever is there. If it's a plus number, it's a positive. If it's a negative number, if it's a minus number, it's a negative, and you go down. So the biggest thing with vertex form, and you're going to see this when we get to that section, is the vertex, because it's called vertex form, the vertex is in your formula, whatever H is and whatever K is. All right, and we're going to, again, talk about this in this example. More important is just you have kind of more detail of what we're looking at. So with that, let's move into our first example. So we've got this first one right here, and we're going to do it two different ways. We're going to use our vertex form, and we're going to do the steps, and then we're going to expand and FOIL to show the trinomial like you have been graphing. So the first thing we're going to do, we have this quadratic in vertex form. It's y equals -2. The whole thing, x plus 5 is being squared, minus 3. So I'm, like I normally do, I'm just going to label my a. I have -2. My h now is, because this is positive, this is a -5, and then k is whatever is there, so this is just a -3. Okay. You don't need to do this every time, but I think it's helpful so you can see the pieces and parts as they are. All right, so then if we're looking at this using our vertex form, you'll be asked to find your vertex. So for both of these, we can say our vertex of this quadratic is going to be -5, -3, and we're going to show that in our graph. So the first thing I'm going to do before I start doing any transformations is I'm going to graph my parent function. It's good to see where you're coming from so you know where you're going. Okay, so my standard -2 to +2, these are all my points. It's, again, not exact because it's graphing by hand. Our AOS, our axis of symmetry, is through the middle, like it always is. The x equals 0. I'm sorry. And so that's our parent function. So I'm going to show each step of the transformation in different colors. Okay, so the first one we're going to do is identify if we have a horizontal shift. Well, we do because we have h is -5. So horizontal shift. Do we have one? We do. We're going to go left 5 units, and that's to the negative side of the x. So we're going to take our vertex and go 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. There we go. All of these points, even the axis of symmetry, will now shift over 5. It is still symmetrical to what it was. So when you shift everything, you should still have a symmetrical graph. Okay, you should still have a symmetrical graph, and I'm going to make this dotted so you can see that it's not my final answer. Okay, compared to like having my final answer in there. Again, my axis of symmetry did move, so it is right here now. And that's just step 1. So step 2, we're going to look at if we have a reflect. Because if we don't, that's fine. And do we have a vertical stretch / compression? Okay, so those are the 2 things you need to ask yourself in this step. So I do have a reflect over x because we have a negative out here. Remember, if it's a negative a, it's we have a negative a, so it's going to be facing down. Okay, that applies here as well. So we do have a reflect over x, which means all of these points are now going to flip down. Okay, so I'm going to do that real quick to show you, and then we'll do our vertical compression. So this should flip over here. It's going to be a mirror image down. So then this should be 4 units this way. So 1, 2, 3, 4. And again, it is symmetrical. So 1, 2, 3, 4. And again, it's not my final graph. I'm showing all the little steps I need to show. Okay, so that's just the reflect. So we did have a reflection over our x, so it flipped down. And now I'm going to show my vertical stretch or compress. So I do have a stretch because a is greater than 1. It's not a fraction. So if you remember from the notes that we did the other day in the video, 4 made it stretch real skinny, and then 1/4 made it really flat. So this is going to stretch a little skinnier. So I'm going to take my points that I currently have, and I'm going to move this down real quick so I have more space. Okay, so hopefully you have that space as well. So I'm going to take the points I currently have. So I've got, let's see, 1, 2, 3, 4, 5, 6, 7. I got 7, -7, -4. I got -6, -1. I've got -5, 0. Okay, and then again, it should still be symmetrical. Okay, that's what I have now. So when I do this part, my x part, I'm going to take them and I'm going to multiply them by 2. So my new table with my new values, I'm going to take my inputs that I have, because my inputs won't change because I'm still plugging them in. Okay, so I'll show this with my -5. So right now, this is the part of Vertex Form I'm looking at, is the -5 input for my x. We're not doing the vertical shift yet. Okay, so I'm just showing you all the steps. You could just do the transformation. So this is my -5. It's currently at 0. So -5 plus 5 is 0. That whole thing squared. Well, that didn't change. Well, that's kind of nice. So I'm going to put a blue point where that is. I'll try again with my -4. So maybe we can see kind of what's happening. So if I have an input of -4, it's currently at -1. So when I get here, I've got +1 being squared, so 1, times -2. So now it's going to be at -2. So same thing with my -3. I should have a -8 there when I'm all done with this. So -3 plus 5 is +2. Squared is 4, times -2 is -8. So you can see my outputs are being multiplied by a 2. So this should be -8 and this should be -2 as well. Okay, so I'm going to make those changes. So -6 should now be at -2. And then this orange point is going to move to a -8. So 5, 6, 7, 8. And it should be symmetrical. Again, dotted lines because I'm not quite done yet. Transformations aren't easy because there's a lot of steps, but if you show it in phases, it helps. Okay, so the last thing that we need to do is we need to do our vertical shift. So I'm going to do that in another color. Let me see. Let's do a darker green. So I'm going to erase this. And so the last thing we're going to do, our third step, is we're going to identify if we have a vertical shift or not. And we do. We have K is a -3, which means we're going to move everything down 3 units. Right? So we're going to take the blue one, because that's where we're at. We're going to take this blue one, we're going to move everything down 3 units. So 1, 2, 3, 1, 2, 3, 1, 2, 3, and then it's symmetrical. So assuming that, we count and, do what we're supposed to, we can get there. And this one I'm going to make a solid because this is my final answer. And do your best to make it parabola. Okay? So that is if you're using transformations. Now, again, it seems like a lot because we're just learning it. So as you've memorized your steps and you get into geometry, it will be quicker. I know when we do this in pre-calc, we just review the steps and it's just a bunch of counting at that point. So because it's new, it's going to seem a little bit more complicated. But I think as you guys use it a little bit this year and a lot next year, I think you'll be okay. So what I want to show you is how to do it with the normal graphing that we've done, not necessarily in Vertex Form. So I'm going to come down here. I'm going to write the one that we're working on because I want you to see that it is the same, that what we did wasn't just make up a whole bunch of stuff, okay? So it should be the negative 2x plus 5 with the negative 3. And I'm going to make my graph a little bit bigger. So if you're doing this right now, I would make your graph a little bit bigger so you have a little bit more room to show everything. So the other way to do this is expand this part, foil or smiley face it, however you like to remember it. And then once you've collected all your like terms, to just graph how we normally graph. So I'm going to do that. I'm going to show you exactly how to do that. So I'm going to expand because the 2 means I have 2 of these binomials. I'm going to do my smiley face or my FOIL, again, however you remember is up to you. It's 25. And then I have 2 5x's. The last one. Sorry, guys. I'll move this over. Okay. So now I need to collect like terms. So I've got negative 2 on the outside. I've got these 2 like terms that can go together. The 5x's. So x squared. I'm going to put it in my descending order like I learned how to do. And now I can take my negative 2 and I can distribute it in. So I've got negative 2x squared minus 20x minus 50, and I still have this minus 3, and I can take those 2 because they are constants. They do not have a variable. I'm going to put them together. So I have this trinomial right here, the negative 2x x squared minus 20x minus 53. All right, so the way we learned how to graph is to take our a, b, and c. So a is negative 2, b is negative 20, and c is negative 53. Okay, if you notice, your a here is the same as your a in the original problem that I gave you up there. Okay, can you see how that a and this a are the same? Okay, that will be true every time. So when we've started, we found our AOS, which is opposite b over 2a. Okay, so opposite b is 20. 2 times a is negative 4, so we get an x of negative 5. All right, so our goal is to have a vertex of negative 5, negative 3. That's our goal. And I'll write that up here. Our vertex is negative 5, negative 3. So even if we do this way, all the algebra, we should still have the same exact graph, same exact vertex. Everything should be the same. So this x value, if you remember, that's where your axis of symmetry goes. So I'm going to go to negative 5. So 1, 2, 3, 4, 5. The graph is a little small, but that's okay. Okay, I've got my axis of symmetry, and I'm going to plug this 5 in to my trinomial to get my y value. So I've got negative 2, negative 5 squared minus 20 times x minus 53. And I'm going to do some math. Okay, we're going to math it up. So negative 2, negative 5 squared is 25. This becomes positive 100. Again, if you have a calculator, you can do this. It's no big deal. I'm just showing all of my steps so I know where all my numbers came from. Negative 2 times 25 is negative 50. So they are big numbers, but once you're done with it, you should get a y equals negative 3, which is what we want because our vertex is negative 3, or negative 5, negative 3, which is exactly what we're looking for. So I'm going to go down here. Okay, so that's where my vertex is. And it is, just in case you're curious, it is a max at that point. Okay. So now what I'm going to do is I'm going to make my table of values. So I'm going to make my graph a little bit bigger. so I can see where my table of values needs to be. So remember your table of values is that XYT chart that we've been looking at. All right, so if my vertex is at -5, -3, I can use -7, -6, -5, -4, -3, okay? And you would just plug in those numbers and solve, okay? So if I plug into my trinomial, and again, you have a calculator, you can plug in these numbers. Your x is your input. So, excuse me. You can do the algebra for all of these. So we've got -7 squared, which is 49. Yeah. So then we've got times -2. This becomes a positive 140. Okay. So then we've got 8, 1, that's what, -98 plus 140 minus 53. So when all is said and done, we should have a y value that is equal to -11. And if we look at our graph, we can check above. Let's go look at our graph. So I'm going to write -11 in here. I want to see where we ended up in this graph just to confirm. So this is the point we're talking about. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's right. So we're at -11. And we're going to do that for every single one. So -7's here. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We know -5 is at -3. So let's find -6. Again, same thing. Plug in your number, do the algebra. So -2, -6 squared, minus 20 times -6, minus 53. This is a really long video. This is -2 times 36, and the positive 120, -72 plus 120 minus 53. So when we do all that math, if we were in class, you would have already told me we should get a lovely -5. So I want to go up, I'm going to put it in my chart. So then find -6, 1, 2, 3, 4, 5, go down 5. I'm going to confirm that's where we are in our other graph, so we're on the right track. So let's see here, 1, 2, 3, 4, 5, we're good. And they should mirror each other. So when you do the algebra for -4 and -3, you should get those same exact numbers. And for the sake of time with this video, I'm going to just go ahead and put it in there and show you my graph. So now when we look at both graphs, they should be fairly similar because again, it's graphing by hand. It's hard for them to be exact, but they do have the exact values and the exact points. Okay, so you can do your vertex form problems using your expand foil, all the algebra, using calculator, and then graphing the way we've talked about. Or you can practice your steps and do your transformations. Okay, so again, it's just an introduction. It's not the way we're going to do things quite yet, but this is really good information for you to know already. So when we do start using it a little bit more and you start seeing it in geometry, you are aware of that. Okay, so I'm going to post this. Pause the video as you need to. I'm just going to post it in Classroom. And if you have any questions, let me know. Send me a message on Remind or email if you post something in Classroom because I don't always see it. Classroom doesn't notify me. So I hope this helps.